Good morning, AP Stat students. We're going to finish up section 2 here with experimentation, um, designing studies, experiments. Let's go ahead and look at this question in a completely randomized design. What is the purpose of having a control group? So why do we need some type of control group? Sometimes it's a placebo, sometimes it's just a group that is not changing anything that they do to measure whether something else is changing. We always need a control group to minimize our confounding variables. We don't want to have any lurking variables. We want to minimize the confounding variables that might be occurring. And thus that reduces our variability. Notice I didn't say we were going to eliminate confounding variables because that's not realistic unless you're in a lab setting to eliminate all variables. You want to minimize them, and then you want to minimize variability. So those are the two essential things. All right. So we talk about statistically significant. It's an observed effect so large that it would rarely occur by chance. We are going to give a number to this later. When I mean later, I'm talking about like January or February. But for right now, when something happens and it's so odd, it's very unlikely that it would just happen by random chance. It probably means that something else is occurring. For example, if I have a die and I roll it, 6 times, and I get the number 4 to come up 5 times. I'm not saying that's not possible, it's just not very likely. So there might be something going on with that die. There could be something statistically significant about it that causes, that is making that come up 4 that many times. Maybe the die has been shaved. It's loaded. So it'd be a cheating die so that you could win or lose more money in a game. So something like that. So we just need to be aware of what that means, and we'll put a little more definition with that later. This is a strong statement. A strong association does not imply causation. Think observational study results. We will look at examples of that later. I can pull one up. I'd like to pull up one example right now. Just an example. U.S. spending on science, space, and technology, as that increases, the number of suicides by hanging, strangulation, and suffocation increases. So there's a correlation there. There's an association. But it's not cause and effect. If it was cause and effect, we would tell our government to not spend any more money on science, space, and technology, and then there would be a lot less hanging, strangulations, and suffocations. So there's other variables at play here. So just that one little example, I think that's important for us to look at. Types of things like that. Okay? We've got to talk about the idea of blocking. I'm not going to read this whole thing. I'm going to summarize. Blocking is when you put people together in common characteristics, and then you run the experiment. It is very similar to a stratified random sample that we learned before. There is a difference. One is for sampling. Stratified random sampling is for sampling. You're not doing any experimentation. That's for an observational study. Blocking is when there's an experiment. You must use the correct terminology on the AP test. I think there's a slide in here later that talks about that. You can't use them interchangeably, but they are very similar. So you can make the connection that they are similar. They really represent the same thing, but you can't use them interchangeably. So blocking, stratified random sampling, blocking is on experiments. So you can block on a gender, you could block on race, you could block on age, all kinds of different things. Sports that you play, you could block all certain teams together and then study each of those teams. So here's an example. They took 10 people. Really should be more than 10. That's not a lot. We should be in the 30s or 40s when we do any type of experiments or sampling. If you don't have at least 30, you're usually going to have issues. But anyway, they did 10 people. They had 4 people that used a smartphone and 6 people that did not. I'm assuming they had like some kind of flip phone, you know, those dinosaur phones, but they don't have a smartphone. So they purposefully divide them. So there's no random assignment here. They take the people with common characteristics and put them together. Then they randomly assign those people to 2 different keyboards. And they randomly assign these people to 2 different keyboards. And then they compare their typing speed. And then they analyze and combine the results. So there's some definitions we already talked about. Okay? Blocking with smartphone. Here's some of the data that came up. So you can see here's a bunch of data points. Here's keyboard A, here's keyboard B. Looks like keyboard A was a little bit faster, but nothing really earth-shattering here. So there's some evidence, but it's not overwhelming. Maybe a little bit. All right. So, but what happens if we block with the smartphone? So, the average typing speed for the smartphone people was 40 words per minute, while the average for non-smartphone people was 26. So let's subtract 14 from each of the typing speeds. Smartphone users to even the playing field. Basically, we're trying to see if there is, we don't want to see if there's a difference between smartphone and non-smartphone users. That's not really our goal here. Not what we're trying to do. Okay. But when they do that, you can see when the blocks are performed wisely, it's easier to find convincing evidence that one treatment is more effective than the other. So keyboard A is more convincing. Let's go back and look at that. So there's no overlap. I think I already mentioned this. Don't mix the language of experiments and language of sample surveys or other observational studies. You will lose credit. More isn't always better in our class. Get to the point, say what you need to say, and be done. More is not necessarily better. Maybe that works in English class. That does not work for us. I'm not saying it works in English class, but definitely don't want to do it. Okay? So women and men respond differently to advertise. Researchers would like to design an experiment to compare the effectiveness of 3 advertisements for the same product. Explain why a randomized block design might be preferable to a completely randomized design for this experiment. So why would we do block? Well, men and women could respond completely different to these. If you put them all together, you're not going to be able to see that. That's basically going to create another variable that you're not going to be, it's going to be a confounding variable with what you don't want. Okay? They want to compare the effectiveness of the 3 advertisements for the same product. So if you block, then you can get to the root of the advertisements and their effectiveness. If you don't block on gender, then the variable of gender is now in play and may cause variability and may cause issues. So blocking as gender eliminates that, and we can look at them separately to see if they respond differently, to see if certain advertisements worked well for certain genders, if they worked for both, or if they worked for neither. You can see it easier. So Part B, outline a randomized block design using 300 volunteers, 180 men, 120 women as subjects. Describe how you would carry out the random assignment required by your design. You should pause the video to try to do this. You can definitely do a diagram as long as you have explanation involved. So that's just something to keep in mind. What you would want to do is separate into the men and women. And then once the women are separated, there's 120 of them. You're going to randomly assign them to 3 groups. How do you do that? You must explicitly spell that out. If I'm going to use the hat method, I'm going to take 120 women names and put them in a hat. I'm going to mix it all up, and I'm going to pull out 40 names. That goes into my first treatment group. Then I'm going to pull out another 40 names, and that goes into my second treatment group. And then the remaining 40 go in the third treatment group. Same thing with the men. You're going to take the 180 men. You're going to, let's just say we're going to try a different randomizing method. I'm going to number them 01 to 180. I'm sorry, 001 to 180. 3 digits, so I need 001. And then I'm going to use a random number table. I'm going to go to a specific line, and I'm going to start to record 40 numbers. I'm sorry, not 40, 60 numbers. 180 divided by 3 is 60. So we're going to have the first 60 people, first 60 numbers selected go into the first treatment group, and then the next 60 go into the second treatment group, and then the last 60 remaining go into the third treatment group. Then we compare the reactions between the different advertisements, and then we combine the results of the men and women and compare results. So that's what you'd want to do. There was space on these if we were taking notes in class, but if you're taking notes on your own paper, then it doesn't matter. Okay? Match pairs design is when you're blocking on a common theme. An example of that is you can match pairs with a pre and a post test. You compare yourself. So we compare your test score before and after the unit. So you get a pre-test, see how you do. You take a post-test, see how you do, and then we compare. That's a match pairs design. So we're blocking on you or a person. It doesn't necessarily have to be a pre and post test, but it must be very similar people. Example could be twins. That match pairs design sometimes compares twins. Or it has to be things that are really, really similar, or people that are really, really similar. In terms of like a weight loss program, you wouldn't want to compare somebody that wears 300 pounds and somebody weighs 200 pounds. They're not the same. They're completely different. If you're comparing 2 males who weigh about 300 pounds and are trying to lose some weight, okay, that could be a match pairs design. You still need a random assignment to decide who's getting what treatment. You're just pairing the people up. I'm going to let you read through this. This is an activity. I've done it in the past. It's been a couple years since I did it, but we definitely cannot do it this year. So take a look and read through the completely randomized design, the match pairs piece of it, analyzing the data, what advantage does match pairs design over completely random. The advantage is you are comparing yourself. So you're not comparing another person. So here were the results in, I don't know if this is a real activity or just a made up one, but here was the results. Sitting, standing, you can't really see a whole heck of a lot. But if you calculate the differences, so if this is the same person here and here, you calculate the difference and you only get one. You can see there is a trend that it's different from standing to sitting. That your blood pressure is higher standing versus sitting. So we're going to make sure we choose the appropriate method. Sometimes block is good and we would want to use it, and sometimes we don't. We just want to keep everybody together. But it is one way to try to eliminate. You're never going to completely eliminate. You want to minimize confounding variables. And block design helps us with that. Match pairs design is also another way to block. You're blocking yourself so you can make those comparisons. Let me know if you have any questions.